Demand for fish protein is on the increase due to high population growth and is putting more pressure on both marine and freshwater stocks. More than 33% of ocean fishing is fully exploited. Aquaculture, the farming of aquatic organisms for profit, is the only way to meet this growing demand. It's the fastest growing sector in the animal protein produce, which is the market of more than $125 billion. To meet the global demand, the production must be increased by additional 50 million tons by year 2030. The only way to meet this demand for aquaculture is through intensification, that is to produce more fish per unit of area and water. Long years of research in the field of aquaculture around the world is on the conclusion that the technology was the key to leverage the potential growth of aquaculture production, and which is identified what they have termed as called the technology gap. Now, the critical problems that is faced with the traditional aquaculture system is the large usage of land, area and water for building ponds for fisheries. 1 hectare of land, which is equivalent to 1 soccer ground, and high usage of water, which is 20 liters per kg, and limited by water quality, which produce only 8 to 10 metric tons of fish. The open security is also a challenge over here because the system is open and not protected. Inefficient disease control and waste removal mechanisms leading to high mortality rate of fishes. This is altogether leading to the poor yield, and the low production statistics goes in this process as 2 kg per meter cube. We are changing the idea of traditional aquaculture by enhancing the leaf circulatory aquaculture system, which is known as RAS. RAS is a scientific phenomena which provides a real-time comfort zone to a high-density aquaculture by maintaining continuously through a closed-loop filtration, auto-feeding, temperature and pH control mechanism. We are enhancing the recirculatory aquaculture system by making the system more compact for farmers, integrating machine learning to make it smarter, and solar panel to make it more power friendly. This is a highly secure system and has little or less dependency on natural fluctuation like rainfall or drought. The recirculatory aquaculture system can produce more than 15 times higher than the current yield of a traditional aquaculture in a limited space. Thinking of a compact, renewable, efficient system, which is leading to a compact structure, low water usage, easy to feed, effective supervision, automatic temperature control, easy to plug and play and install, high yield environment, easy to upgrade, automatic filtration and UV cleansing, productivity increases 15 times than the simple pond. Now our current structure goes as follows. It's the filtration process. We are using the UV and the DOM filters, the oxygenator, the carbon dioxide degassers, the auto feeders and the DOM filters. So these are generally used to remove the solid waste, nitrate removal, microorganism cleansing and providing the correct ecosystem to the fishes. Our advanced solution is easily scalable, easily upgradable, lower power consumption, easy to maintain, high scale production with least or less mortality rate, and this aquaculture setup of 1500 square feet can produce equivalent quantity of fishes that are being produced by 1 hectare of traditional aquaculture system. It's a modular system, it's compact and scalable with investment around 45-40% return on investment of a production cycle. It has a solar power integration to make it more eco-friendly, machine learning integration to help the better analytic structure and which helps in better closed loop control and monitoring, and it also has a social impact impacting the GDP of a country. The value addition to the system using the 3D experience platform, we have introduced the Biomass Savior, the solar panel integration, aquaponics, multi-story to reduce the footprint, retail and distribution, sales to increase the global food production, system reduces 85% of water and good sustainability. We are using DS3 experience platform by using CATIA, SolidWorks, Simulia, Internet of Things, Enovia to maintain the change, and the project Delmia. This is digitizing the production, optimizes the production cost, quality and quantity, optimize use of seeds, chemical, water, ensuring end-to-end food traceability and high visibility to control over assets, operation performance, managing environmental compliance and risk prevention. Our 3D experience platform is we are using is a part of the 3 Experience Startup Accelerator already working for sustainability, energy, agriculture, and forestry. Eco-friendly amalgamation of existing startups. Nano aquaculture system could be used one of the different channels of business, and also nano aquaculture system has the potential to enhance the 3D Experience Lab. We are able to upgrade the agriculture to nano aquaculture, going to help the future. The global footprint is going to be changed into a nano footprint by global business generation. Global economy will increase, the availability of fresh and disease-free fishes will be produced. If we can change the digital future of agriculture and forestry, we can definitely have a better tomorrow. Thank you for